Okay, guys, so we are starting in on a little miniature unit, if you want to think of it that way, for solving quadratic equations. And again, this is something that you guys have seen before. We're going to start in today just looking at the factoring piece. So the big thing with the factoring is to recognize that the whole point of factoring is, first off, we need to get it set equal to 0, and then we're going to break it down into something a little more manageable. So for example, we're going to be using this with the understanding that if we can get a times b equal to 0, then we can use the idea that either a equals 0 or b equals 0. And the reason that we can use that then we can set one of the factors equal to 0 and solve, and then we can do the same thing with the other factor. So just as a quick review, we're going to look at some different factoring types of questions. Okay, so if you notice in this first example, you have 4 different terms. When you have 4 different terms, the first thing that you always want to look for, regardless of how many terms that you have, is you want to look for a greatest common factor. In this case, if you look, we have a greatest common factor of 2. So what we can do is we can divide 2 by everything, because if we divide 0 by 2, that is also going to be 0. So at this point, we have x cubed minus 2x squared, minus 3x squared, minus 3x plus 9. And again, that's going to equal 0. Once we do that, since we have 4 terms here, we're going to be factoring by grouping. And what that simply means is you're going to put the first 2 terms in the first set of parentheses, and then the second 2 terms in the second set, or excuse me, the third and fourth terms in the second set. Okay, from there, what you're going to do is you can now factor out a greatest common factor from each one of these. So if I look at this first one, I have a greatest common factor of x squared, which then will leave me with x minus 3. And then again, we're going to take and do the same thing from the second set. We're going to look here, and we can pull out a 3. Notice we do have a negative here in front, so it's a negative 3, which will then change this to a positive x and a negative 3 here, that equal to 0. Now notice, when we look at this, we have a matching set of parentheses. We want to have a matching set of parentheses because your next step is going to be to create groups. And so you're going to put the matching set in one parenthesis, and then you're going to put what I call the leftovers in the other set. So x squared minus 3 will go in the other set. Again, we have this currently equal to 0. Once you get to that point, you're going to set each factor for each set of parentheses equal to 0, and then you're going to solve for x. Okay, so in that first part there, you can go ahead and do x minus 3 equals 0. When we add 3 to each side, we're going to get x equals 3. And then we're going to do the same thing with the x squared minus 3 equals 0. So when we move that 3, we get x squared equals a positive 3. Reminder, when you do the square root, you get a positive and a negative version of that radical. Okay, so the 3 solutions to the equation, you get the 3, you have a root 3, and you also have a negative square root of 3 for your 3 answers. Okay, so when you then go ahead and look at example number 2, again, what you're going to do is you're going to go ahead and take out a greatest common factor of 3. We're going to divide everything by that 3. And then group. Okay, so again, we're going to put the first 2 in a parenthesis, the last 2 in a set of parentheses, and we're going to go ahead and take out a greatest common factor. So we have x squared. When we take an x squared out there, we're left with x minus 2. And then we want to go ahead and take out a negative 2, because again, we want to have that parenthesis match the first parenthesis that we just did. If we took out a positive 2, it would not match. Okay, and then you put your matching parentheses, your matching factor in one set of parentheses, you put the leftover in the other one, and then you go ahead and set each factor equal to 0. So x minus 2 equals 0, we get x equals 2 for one of our solutions. And then again, we have x squared equals a positive 2, so when you do the square root, you get positive, negative square root of 2. So you have 3 solutions yet again. Now, when you look at the next example, notice there are only 3 terms in this example. So what we want to do to start with is we want to go ahead and expand that to be 4 terms. Now, before I do this, just a quick disclaimer, Some of you probably have learned other ways to do this type of factoring. Maybe it's a guess and check. There is more than one way to do this. There are many ways to do this. But what I've found over the years is this is the most consistent way if you're having problems seeing right out of the gate what the possible factors could be. So let's go through this. So first thing that you would want to do is you want to multiply your first and your last term. So the first thing, multiply, and I'm going to call that AC because that's your A term and your C term. Reminder, the reason I call that AC is it's in the form ax squared plus bx plus c. Multiply those two values together, you get negative 12. So the question you want to ask yourself here is what multiplies to give me a negative 12 that adds, and that adding piece is going to be the coefficient of my b term, or the coefficient of that x. So in this case, we have a positive 1. So what multiplies to give us negative 12 that adds to give us 1? And when I look at that, the answer to that is just a 4 and negative 3. When I multiply that, I get negative 12, and I add the negative positive 1. What we're going to do with that is we are going to take that middle term and split it up. So that 2x squared and the minus 6, those stay exactly the same. This middle term, this x term, is going to be split into a positive 4x and a negative 3x at that point. And then again, now we have 4 terms, and so what we're going to do from here is go right back to what we did before. We're going to go ahead and group. And so now we can look at this, and we have a 2x in this first set of parentheses. When I take out the factor 2x, I'm left with x plus 2. I can take out a negative 3. Again, my whole goal is to get matching parentheses, so it has to be a negative 3, not a positive 3. And then I can go ahead and put my matching parentheses, and again, what I call my leftovers, so the part on the outside, 2x minus 3, there. Okay, and then from that point, I can go ahead and set each one equal to 0 and solve. So I get negative 2 for this one. And then for the other one, I get 2x minus 3 equals to 0. So 2x equals to positive 3, positive 3x. Okay? So again, my very first step is here, multiplying that first and last term together to get that value. They then help us figure out what multiplies to give us negative 12, what adds to give us, and again, that number comes from that b term, that middle coefficient. Okay, so what we have to finish here, notice we have a lot of steps here. Guys, don't get so bogged down in the steps that you just don't think, like that you forget to think about this. So for many of you, you may look at this example, and it might be a little bit easier just to kind of process this and split it up and think like, okay, I'm going to do some, if I'm going to look at this, I'm going to split x to the 4th as x squared, and then I'm going to figure out what multiplies to give me positive 2, but adds to give me negative 3, and that's going to help fill in that. That is okay. If you want to do it that way, that is fine. But another way that you could possibly do this that would make more sense to some of you, because you're not used to seeing this x to the 4th here, is you can go ahead and rewrite it. Okay, now notice that step 1 says rewrite, and then it says in blank form. Okay, that blank is just quadratic form. Quadratic meaning that you have the x squared as your first term. Now here's the thing. It's going to look something like this. So don't get bogged down in this. You get x squared minus, and then you get, let me actually do this in a different color, make it a little bit easier for you. Sorry. So we got x squared. Okay, so we have a term squared plus another term. Okay, and just bear with me for a second. What you're going to do is you're going to make a substitution for this x squared. So step 2 is going to say substitute your x squared for maybe a y, and you can pick whatever variable you want. Okay, it doesn't have to be y. So in other words, here you're going to say, okay, it's going to be y squared minus 3y plus 2. Then you're going to factor normally. Now we don't have to do the whole breaking it up into 2 separate, or into 4 terms like what we did in the last part, because we don't have a number out here. So since we don't have a number out here, what we can do is say, okay, what multiplies to give me a positive 2, but adds to give me a negative 3. So that y squared goes to y and y. To give us a positive 2 for multiplication, but add to give us a negative 3 is going to be negative 2 and negative 1. Okay, again, what we're going to do is set each factor equal to 0. And then solve for each. Notice here, in the case, instead of solving for x, what we're actually solving for is for y. So we have y minus 2 equals 0, y minus 1 equals 0, so we get y equals 2, or y equals 1. Okay? And then what you're going to do is you're going to substitute back your original x squared. Okay, so if you notice it says we're going to replace y with x squared and solve for x now. So again, kind of bear with me here on this long substitution here. So basically what we're saying is if y equals 2, then we know that x squared equals 2. And so then when we solve that, we're going to do the square root of each side. So we get x equals the positive and negative root 2. Same thing here. We get y, we had equals 1. And if we substitute back in that x squared equals 1, we get x equals positive negative root 1, which is then just 1. Okay? So you actually have 4 solutions in this case. You have positive root 2, you've got negative root 2, you've got 1, and you've got negative 1. Okay? So again, here's the thing. I kind of showed you guys up here all the way at the very beginning that I can break this x to the 4th into x squared and x squared. Again, I can do negative 2, negative 1 to get us that multiply addition piece there. And then again, I could just take x squared minus 2 equals 0, and then x squared minus 1 equals 0, and I can solve and get the same set of solutions. So what I've shown you is 2 different ways. If the double substitution thing confuses you, but what I just did in the red makes more sense to you, go for it. My job is to give you different ways to solve the problem, and then for you to figure out which way you are more comfortable with. Okay? So what we're going to look at is I'm going to do 1 with the double substitution, and then 1 without the double substitution. Okay? So bear with me. So I'm going to do this first one without the double substitution. So if it makes sense to you, feel free to use it. For me, it makes sense. Okay? So I know that that x to the 4th is going to be split equally. So x squared, x squared. And then I'm going to say, okay, what multiplies to give me this 8, but is going to add to give me the negative 6. And if I'm looking at those 2 numbers, I'm going to have a negative 4 and a negative 2. And then from there, I can set each factor equal to 0. And so I would have x squared, sorry about that, x squared equals 4. When I do the square root of each side, I would get a positive and negative 2. And then again, x squared equals 2, would get a positive negative root 2. That is, again, kind of the shortcut way that I showed you on the previous page in red. So then, again, if that doesn't make sense to you, what I would do for the second one is I'm going to show you the double substitution route. Okay, so I'm going to let y equal, oops, sorry about that, hands are up there. Let y equal x squared. So I'm going to use some substitution here. So this is going to become y squared plus 2y minus 3. And then I can go ahead and factor this to be y plus 3, y minus 1, because again, I'm looking for what multiplies to give me negative 3, but adds to give me a positive 2. I can solve this. So I get y equals negative 3 for the first set, y equals 1 for the second set. But then again, I'm going to substitute back in that x squared. Oops. And I'm going to do that for both of those. Okay, now, if you guys recall from Algebra 2, if you do the square root of a negative number, that's going to give you an imaginary number. So at this point, you have plus minus I root 3, imaginary number. And then again, here you have a positive, negative 1 for that. So you actually have 4 solutions, only 2 of which are real numbers. Okay, so hopefully that makes some sense. Again, as always, if you guys have questions, let me know. I know I go somewhat quickly through some of these videos, but these are all pieces that I'm hoping you guys are familiar with and have seen before. Thanks.